Hi and welcome back. Today we are going to be discussing transformers 26240. Please open up your code book on pages 232, 233, 234 and 235. Now transformers, there's many things that we have to look at with transformers. We have to look at the sizing, the spacing, where we're going to be locating them, but also most importantly is how are we going to feed the primary and secondaries of these transformers. So we also have to deal with tables 1, 2, 3, and 4 of the code book. So as you start to get larger in transformers, you may be feeding the transformers with single conductors, which would relate to tables 1 or 3. So copper is table 1, single conductor would be, aluminum would be table 3. As we have smaller conductors, for example 10 kVA, 12.5, 25 kVA, 50 kVA, we would be feeding those transformers with 2 conductor or 3 conductor cables. So we would be using either tables 2 or 4. So for now, what we're going to be doing is basing our ampacities out of copper, not out of table 1. So we're going to be using table 2 for our calculations. But first of all, let's go take a look on page 232, which discuss transformers. In this subsection, 26240, subrule 1, transformer shall mean a single-phase transformer, a polyphase transformer, or a bank of 2 or 3 single-phase transformers connected to operate as a polyphase. So in this case, we're just going to start off with the bare basics, a single-phase transformer like we showed you upstairs in the lab. Nothing special, single phase. We're not going to get into a unit substation, but however, subrule 2 talks about transformers shall be constructed so that all live parts are enclosed unless they are installed installed to be inaccessible to unauthorized personnel. So something like that could mean a vault, but we're not going to be dealing with a vault. 99% of the time the transformers are enclosed in some form of a housing where you do not have any access whatsoever to the primary and secondary conductors, except if you take the covers off. Subrule 3, conductors and cables used for connection to air-cooled, dry-type transformers shall be permitted to enter a transformer enclosure through the top only when the transformer is marked to permit such entry. I've never seen a transformer marked for approval for top entry. You normally want to come in on the lower half of a transformer on the sides. That's to do with the problems of heat. Transformers generate a lot of heat. Heat rises, and if you have your conductors at the top, the heat has a detrimental effect. So you technically have to derate those conductors. All right, we're not going to talk about 26242, outdoor transformers and unit subs, because we're just dealing with dry core, open ventilated transformers. Just the basics. One thing I forgot to mention to you when we were upstairs at the third year lab was transformers of dry core, especially 26246 we're dealing with. Open ventilated type shall be mounted so that there is airspace of not less than 150 millimeters between transformer enclosure and between a transformer enclosure and any adjacent surface, except except floors. So notwithstanding subrule 1, where the adjacent surface is a combustible material, the minimum permissible separation between the transformer enclosure and the adjacent surface shall be 300 millimeters. And subrule 3 says, notwithstanding sub-rule 1, so forget about what we just read, where the adjacent surface is the wall on which the transformer is mounted, the minimum permissible separation between the enclosure and the mounting wall shall be 6 millimeters if the adjacent surface is made of A, non-combustible material, B, combustible material adequately protected by non-combustible heat insulating material other than sheet metal, or sub-rule C, combustible material shielded by grounded sheet metal with an airspace of not less than 50 millimeters between the sheet metal and the combustible material. So in reality, because of heat, which is our #1 biggest problems with transformers, we have to keep a minimum, as per sub-rule 1, 150 millimeters away from any combustible surfaces. So that is 6 inches. Sub-rule 2 says where the adjacent surface is a combustible material, the separation has to be 300 millimeters or 12 inches. So for example, if we had a transformer located next to a drywalled wall, that transformer has to be at least 300 millimeters or 12 inches, 1 foot away from the wall. The paper will burn. And sub-rule 3 states if you have non-combustible material along that wall, you could be as close as 6 millimeters. And that is not plywood that has been fire treated. That would be, plywood is still an organic material. You would have to use a product such as a fiber board, Wonder Board, that kind of stuff, where it's a concrete material. So you could be as close as 6 millimeters. Next, 26248. So a disconnecting means shall be installed on the primary circuit of each power and distribution transformer. That's pretty obvious. You need to disconnect it. You need to have some form of disconnecting means. Now, in our example, we're not going to get into high voltage power and distribution equipment, so we're not dealing with anything over 750 volts. So we don't have to deal with 26250. We're not going to deal with overcurrent protection for power and distribution under 750 volts. We're just going to keep it nice and simple. However, we are going to be reviewing 26254 and 26256. And we're just going to make it a nice, easy type of calculation. I'll go over the rule and then we'll go over this example right beside me. So 26254 talks about overcurrent protection for dry type transformer circuits rated at 750 volts or less. And 26256 talks about the conductor size of transformers. So 254 sub-rule 1 states, except as permitted by sub-rule 2, each ungrounded conductor of the transformer feeder or branch circuit supplying the transformer shall be provided with overcurrent protection rated or set at not more than 125% of the rated primary current of the transformer. And this primary overcurrent device shall be considered as protecting secondary conductors rated at 125% or more of the rated secondary current. So our primary fuse or overcurrent device can protect the secondary conductors of the transformer as long as the conductors are rated at 125% or more. Sub-rule 2. I'll let you read that on your own. But sub-rule 3 states, where a value not exceeding 125% of the rated primary current of the transformer as specified in sub-rule 1 does not correspond to the standard rating of the overcurrent device, the next higher standard rating shall be permitted. So for example, what happens is, let's say you do a load calculation on a transformer and you add in the 125% of the transformer overcurrent device, then you could go up to the next standard size. So if you come to, let's say, 16 amps for your FLA, full load current, you could then bump up to 20 amps. That is what that rule is stating. So we are going to take a break right now, and then we're going to come back in a couple minutes and talk about conductor sizes for transformers.